Welcome viewers, in this video we will see the details about the superposition theorem available in the circuit theory. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, link is given in the description box. Now we'll go to the topic. The superposition theorem, we'll see the details about superposition theorem. In a linear circuit containing more than one source, the current that flows at any point or the voltage that exists between any 2 points is the algebraic sum of current or voltage that would have been produced by each source taken separately with all other sources are removed. So the superposition theorem is the name itself, superposition. In any linear circuit, either the current or voltage exists, there are n number of sources available, mean we can consider only one source at a time, remove the remaining sources, then consider the second source, remove the other sources, such that we need to find the current and voltage. So the final value is the algebraic sum. For example, we have two sources available, mean initially we need to consider only one source, we need to find either voltage or current. Then we need to consider only second source, by removing the first source we need to find current or voltage. So the final value is nothing but algebraic sum of the first current 1 and current 2. So that is the statement given by the superposition theorem, algebraic sum of current or voltage, right? So that is separately we need to find separately. We need to consider only one source, other sources are removed, right? So the removal of ideal voltage source mean it is short circuiting. So we need to remove either current source or voltage source. So if you remove the ideal voltage source, mean it is a short circuiting. After removing voltage source, we need to make a short circuit. So ideal, similarly removal of ideal current source mean replacing it by open circuit. If you remove the current source, we need to keep in the open circuit. Removal of practical voltage source or current source mean replacing by its internal resistance. For ideal voltage source and ideal current, there is no internal resistance. So that ideal voltage source mean short circuited, ideal current source mean open circuited. For practical voltage or current source mean it is replaced by the internal resistance. Right? So this is the statement given. Based on the statement, we need to remove the source. While removing, what we need to do is given clearly in the statement. Right. Now we'll go for the example circuit, example problem, so that we are able to understand clearly. So consider this linear circuit contain two voltage source E1 and E2. Our aim is to find the current flowing through this load resistor RL. That is a current IL we need to find. So this IL is due to E1 as well as E2. And other two resistors available R1 and R2. So according to superposition theorem, what we need to do? We need to consider only E1. E2 should be removed. Removed means short circuit. With only E1, we need to find what is the current flowing through the RL. The second step, E1 is removed. That means short circuited. Only we need to consider E2. With that E2, we need to find what is the current flowing through RL. So the algebraic sum of both the current is nothing but total current flowing through the load resistance RL. That is the statement given by superposition theorem. Considering E1 alone, then considering E2 alone, we need to find current. The algebraic sum of both the current is the total current flowing through RL. So that is the given. Now we will see how it is possible, how it is correct, right? So in this circuit, let us consider E1 is greater than E2. Let E1 be the greater than E2, so that IL is the load current flowing through the load resistance. This IL is nothing but load current flowing through the resistance, right? So the net voltage, so due to that the net voltage is nothing but E1 minus E2, because we consider E1 is greater and E2 is lesser, right? So what is the total resistance in the circuit? The total resistance is nothing but R1, RL and R2, right? The load resistance, apart from that another two resistors are available. So R1 plus R2 plus RL, right? So the voltage is E1 minus E2. The resistance is R1 plus R2 plus RL based on the circuit. Now we'll go for the further calculation, right? So based on that, what is the load current IL? The load current IL is nothing but I equal to V by R. V is E1 minus E2. The voltage is E1. We consider E1 is greater, E2 is lesser. So E1 minus E2 divided by resistance. Resistance is R1 plus R2 plus RL. So the normal Ohm's law. I equal to V by R. V is E1 minus E2. R is R1 plus R2 plus RL. Now we split these two terms. Here E1 minus E2 available. The terms are splitted. So E1 divided by R1 plus R2 plus RL minus E2 divided by R1 plus R2 plus RL. Right. So what is this? This is nothing but the considering only the voltage source E1. So that we can take it as IL dash. IL dash is the current flowing through the load resistor RL due to only voltage source E1. Similarly, this term is nothing but current flowing through the load resistance due to only E2. So that is taken as IL dash. So it is flowing in opposite direction, so that it is minus IL dash. The sum of these two is nothing but the total current flowing through the load resistance RL, that is IL. So this is the statement given by the superposition theorem. So while writing the equation, it is clearly we are able to understand this term is due to only E1, current flowing through due to only the source E1. This term current flowing through the load resistance RL due to only voltage source E2. So the sum of these two is nothing but IL. So in the problem we can do, first we can consider only E1. We can find IL dash. E2 is removed. Then consider only E2. E1 is removed. Find the term, that is IL dash, IL double dash. So sum of these two is the total current. Right? So this is the description given. Based on that description is verified with the equation. I will go for the further details. So from the equation, IL dash is the current flowing through RL because of E1 alone, flowing from A to B while E2 is 0. Right? So IL dash is current flowing through the RL because of only E1. E2 is removed, that is flowing from A to B, taken as positive. IL double dash is the current flowing through the RL because of E2 alone. Then E1 is removed but flowing from B to A, negative direction. Right. So IL is the current flowing through RL when both the sources are acting simultaneously. So by adding IL dash and IL double dash, we will get the total load current flowing through the load resistance RL. Right. This is the statement given by the superposition theorem. Right. Now we'll see that superposition theorem can be applied for finding the current through or voltage across a particular element in a linear circuit containing more than two sources. But this theorem cannot be used for calculating the power. Right? So the limitation is there. We are able to find either current flowing through the element or voltage across the element having the two or more voltage or current sources in a linear circuit, but we cannot find the power in the circuit by using that. Superposition applicable only for current source or voltage source to find current flowing through the element or voltage across the element, not applicable to find the power. So in this video we discuss what is the statement of the superposition theorem, and also we verified with the example problem. Right? So that the total current is nothing but sum of the current due to source 1 and source 2. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.